Bubble sort, rearranging books on a shelf by repeatedly swapping adjacent books if they are in the wrong order, akin to organizing books alphabetically by manually comparing adjacent pairs. Selection sort, selecting the smallest book from the unsorted pile and placing it in the sorted section, akin to sorting books by repeatedly choosing the smallest one and moving it to the beginning of the shelf. Insertion sort, inserting books into the correct position on the shelf by shifting existing books, akin to sorting books by inserting each one into its appropriate place among already sorted books. Merge sort, dividing books into smaller groups, sorting each group, and then merging them back together, akin to sorting books by first dividing them into smaller categories, sorting each category, and then combining them. Quick sort, selecting a pivot book, rearranging books so that those less than the pivot are on the left and those greater are on the right, and recursively sorting the subgroups, akin to sorting books by choosing a book. Rearranging so that smaller books are on one side and larger books on the other, and repeating the process. Heap sort, converting the pile of books into a heap, repeatedly removing the largest book and adjusting the heap, akin to sorting books by arranging them into a heap and then repeatedly selecting the top book until the heap is empty. Counting sort, counting the number of occurrences of each book and then placing them in order, akin to sorting books by first counting how many times each title appears and then arranging them accordingly. Radix sort, sorting books based on each digit of their call numbers, akin to sorting books by first considering the first digit of their call numbers, then the second digit, and so on. Bucket sort, dividing books into buckets based on a range of values, sorting each bucket individually, and then merging them, akin to sorting books by first dividing them into categories based on certain criteria, sorting each category, and then combining them. BOGO sort, randomly rearranging books until they are in order, akin to sorting books by repeatedly shuffling them randomly until they happen to end up in the correct order. Binary search, finding a specific book by repeatedly dividing the sorted shelf in half and discarding the half that cannot contain the book, akin to finding a book by checking the middle of the shelf, then the middle of the remaining section, and so on. Linear search, searching for a specific book by examining each one in order until the desired book is found, akin to finding a book by looking through each one on the shelf until the right one is located. Depth first search, DFS, exploring the library by starting at one section and moving as deeply as possible before backtracking, akin to exploring the library by starting at one corner and moving through each aisle before returning to the main path. Breadth first search, BFS, exploring the library by visiting all adjacent sections before moving on to the next level, akin to exploring the library by visiting all nearby aisles before moving to those further away. Dijkstra's algorithm, finding the shortest path from one book to another by iteratively considering the closest books, akin to finding the shortest route from one book to another by considering nearby books first. A search algorithm asterisk, finding the shortest path from one book to another by considering both the distance already traveled and the estimated distance to the destination, akin to finding the shortest route from one book to another by considering both the current distance and the expected distance remaining. Bellman-Ford algorithm, finding the shortest path from one book to another while accounting for the possibility of negative edge weights, akin to finding the shortest route from one book to another while considering the possibility of obstacles or detours. Floyd-Warshall algorithm, finding the shortest paths between all pairs of books in the library, akin to finding the shortest routes between all possible combinations of books. Kruskal's algorithm, finding the minimum spanning tree of the library by iteratively adding the shortest edges that do not form cycles, akin to finding the optimal way to connect all sections of the library with the shortest total distance. Prim's algorithm, finding the minimum spanning tree of the library by iteratively adding the closest books to the growing tree, akin to finding the optimal way to connect all sections of the library by starting with the closest ones and expanding outward. Topological sorting, arranging books in order such that for every directed edge from book A to book B, A comes before B in the order, akin to arranging books such that prerequisite books come before those that require them. Kahn's algorithm, performing topological sorting by repeatedly removing books with no prerequisites, akin to arranging books by first selecting those with no dependencies and then removing them from consideration. Tarjan's algorithm, finding strongly connected components in the library, akin to identifying groups of books that are interconnected and cannot be separated. Berufka's algorithm, finding the minimum spanning tree of the library by iteratively adding the shortest edges that connect different components, akin to finding the optimal way to connect different sections of the library by choosing the shortest available connections. Bloom filter, checking whether a specific book is in the library's collection by consulting a probabilistic data structure, akin to determining whether a book is in the library by consulting a list of potential locations where it might be found. Suffix array, indexing the suffixes of all books in the library to facilitate fast substring searches, akin to indexing the endings of book titles to quickly locate books by their titles. Suffix tree, storing all suffixes of all books in the library in a tree structure to facilitate fast substring searches, akin to organizing all possible endings of book titles in a tree to quickly locate books by their titles. Tree, prefix tree, storing a dictionary of book titles in a tree structure to facilitate efficient prefix searches, akin to organizing book titles in a tree where each node represents a common prefix shared by multiple titles. B-tree, organizing books in a balanced tree structure to allow for efficient insertion, deletion, and searching, akin to organizing books on shelves in a way that minimizes the number of shelves that need to be searched to find a specific book. Red-black tree, maintaining a balanced binary search tree of books to ensure efficient operations, akin to organizing books in a way that ensures the shelves remain evenly filled and easy to navigate. AVL tree, maintaining a balanced binary search tree of books by performing rotations as needed to ensure balance, akin to organizing books on shelves in a way that keeps the shelves level and prevents them from tipping over. Splay tree, rearranging books in a binary search tree based on recent access patterns to improve search performance, akin to organizing books on shelves based on how frequently they are borrowed to make popular books more accessible. Quad tree, dividing the library into quadrants and storing books in a hierarchical tree structure to facilitate spatial searches, akin to organizing books in a way that allows them to be quickly located based on their physical location in the library. Octree, extending the concept of a quad tree to 3 dimensions to facilitate spatial searches in a 3D library, akin to organizing books in a way that allows them to be quickly located in a multi-level library with multiple floors. Bloomier filter, combining the space efficiency of Bloom filters with the lookup capabilities of hash tables to efficiently store and retrieve book information, akin to storing book information in a compact data structure that allows for fast lookups. Dancing links, algorithm X representing sets of books as linked lists to efficiently solve exact cover problems, akin to organizing books in a way that allows for efficient selection and removal of subsets. Miller-Rabin primality test, determining whether a book's call number is likely to be prime using probabilistic methods, akin to estimating whether a number is likely to be prime based on certain properties. Pollard's row algorithm, finding factors of a book's call number by iteratively generating a sequence and identifying cycles, akin to identifying factors of a number by repeatedly applying a function until a repeating pattern is observed. Euler's totient function, counting the number of books with call numbers coprime to a given number, akin to determining the number of books that do not share any common factors with a specific book. Chinese remainder theorem, finding the smallest call number that satisfies a set of modular congruences, akin to determining the smallest number that leaves remainders when divided by multiple divisors. RSA cryptosystem, encrypting and decrypting book titles using public and private keys, akin to securing information by encoding it in a way that requires a specific key to decode. Diffie-Hellman key exchange, negotiating a shared secret between 2 parties over an insecure channel, akin to agreeing on a shared book without revealing its title in a crowded library. Knuth-Morris-Pratt algorithm, searching for occurrences of a specific word within a book by exploiting patterns in the word, akin to finding occurrences of a specific word in a book by efficiently skipping ahead when a mismatch is encountered. Boyer-Moore algorithm, searching for occurrences of a specific word within a book by comparing it against the text from right to left, akin to finding occurrences of a specific word in a book by starting from the end and moving backward. Rabin-Karp algorithm, searching for occurrences of a specific word within a book by hashing substrings and comparing hashes, akin to finding occurrences of a specific word in a book by comparing checksums of potential matches. Suffix automaton, constructing a finite automaton to recognize all occurrences of a set of words within a book, akin to designing a machine that can efficiently identify specific patterns within a text. Z algorithm, string matching, finding occurrences of a specific word within a book by computing a string similarity metric, akin to identifying similar passages within different books. Suffix automaton, constructing a finite automaton to recognize all occurrences of a set of words within a book, akin to designing a machine that can efficiently identify specific patterns within a text. Z algorithm, string matching, finding occurrences of a specific word within a book by computing a string similarity metric, akin to identifying similar passages within different books. Knapsack problem, selecting a subset of books with the highest total value that fits within a limited carrying capacity, akin to choosing a selection of books to borrow from the library based on their value and weight. Traveling salesman problem, determining the shortest route that visits each section of the library exactly once and returns to the starting point, akin to planning the most efficient route for browsing all sections of the library. Longest common subsequence, finding the longest sequence of books that appears in the same order in two different shelves, akin to identifying the longest matching passages between two books. Longest increasing subsequence, finding the longest sequence of books that appear in increasing order on a single shelf, akin to identifying the longest stretch of books arranged in alphabetical order. Longest palindromic subsequence, finding the longest sequence of books that reads the same forwards and backwards, akin to identifying the longest passage that remains unchanged when read backwards. Edit distance, calculating the minimum number of operations required to transform one shelf of books into another, akin to determining the smallest number of changes needed to make one passage match another. Maximum subarray problem, finding the contiguous sequence of books with the largest sum of values, akin to identifying the most valuable stretch of books on a shelf. Maximum submatrix problem, finding the rectangular area of the library with the largest total value, akin to identifying the most valuable arrangement of books within a specific section. Minimum cost flow, determining the most cost-effective way to move books from one section to another, akin to optimizing the distribution of resources within the library to minimize expenses. Longest path problem, finding the longest sequence of sections that are connected by direct paths, akin to identifying the longest chain of interconnected sections within the library. Critical path method, identifying the sequence of tasks that must be completed in order to finish a project in the shortest possible time, akin to planning the most efficient way to complete a library renovation. Shortest common supersequence, finding the shortest sequence of books that contains all books from two given sequences, akin to creating a merged reading list that includes all recommended books from two sources. String matching algorithms, searching for occurrences of a specific pattern within a larger text, akin to finding instances of a particular phrase or keyword within a book. Set cover problem, selecting the smallest number of book categories that contain all books in the library, akin to minimizing the number of shelves needed to display all books by grouping them into categories. Matrix chain multiplication, computing the most efficient way to multiply a series of matrices together, akin to determining the optimal order in which to process a series of library tasks to minimize time and effort. Bellman-Ford algorithm, finding the shortest paths from a given book to all other books in the library, akin to determining the quickest routes from a specific book to every other book in the collection. Floyd-Warshall algorithm, computing the shortest paths between all pairs of books in the library, akin to calculating the most efficient routes between every possible combination of books. Johnson's algorithm, finding the shortest paths between all pairs of books in the library, even in the presence of negative edge weights, akin to calculating the most efficient routes between every combination of books while considering obstacles or challenges. Minimum spanning tree algorithms, determining the optimal way to connect all sections of the library with the shortest total distance, akin to planning the most efficient layout for bookshelves to minimize walking distances for patrons. Suffix tree, Indexing the endings of book titles to facilitate quick searches for specific words or phrases, akin to organizing an index of common terms or topics to help readers locate relevant materials. Tree, prefix tree, storing book titles in a tree structure to facilitate efficient prefix searches, akin to organizing books in a way that allows readers to quickly find titles that begin with specific letters or words. B-tree, organizing books on shelves in a balanced tree structure to ensure efficient insertion, deletion, and searching operations, akin to arranging books on shelves in a way that minimizes the effort required to find or replace individual titles. Red-black tree, maintaining a balanced binary search tree of books to ensure efficient storage and retrieval, akin to organizing books on shelves in a way that prevents overcrowding and ensures easy access to all titles. AVL tree, balancing a binary search tree of books to optimize search performance, akin to arranging books on shelves in a way that ensures each shelf contains roughly the same number of titles and minimizes the need for extensive searching. Splay tree, rearranging books in a binary search tree based on recent access patterns to improve future search performance, akin to reorganizing shelves based on which books are most frequently borrowed or referenced by patrons. Quad tree, dividing the library into quadrants to efficiently search for books based on their physical location, akin to dividing a map into regions to help users find nearby points of interest. Topological sorting, arranging books on shelves such that no book is placed before its prerequisite books, akin to organizing books in a way that ensures readers can only access advanced topics after mastering the necessary foundational materials. Dijkstra's algorithm, finding the shortest path from a starting book to all other books by iteratively exploring neighboring books, akin to navigating through the library by always choosing the closest available book until reaching the desired destination. Prim's algorithm, constructing a minimum spanning tree of interconnected books by greedily selecting the shortest edges, akin to designing a library layout where sections are connected in the most efficient way possible to minimize overall walking distance. Kruskal's algorithm, finding a minimum spanning tree by repeatedly adding the shortest available edges while avoiding cycles, akin to designing a library layout by connecting sections with the shortest paths possible without creating loops. A search algorithm asterisk, navigating through the library efficiently by considering both the actual distance from the starting book and the estimated distance to the destination, akin to planning a route through the library that minimizes both physical distance and anticipated obstacles. Breadth-first search, BFS exploring all neighboring books of a given book before moving on to the next level of neighbors, akin to systematically searching through shelves in the library by thoroughly examining all books on one shelf before moving to the next. Depth-first search, DFS traversing through the library by exploring as far as possible along each branch before backtracking, akin to searching through the library by delving deeply into one section before moving on to another. Fibonacci heap, maintaining a priority queue of books efficiently, akin to organizing a queue of books to be borrowed or returned in a way that minimizes the time spent waiting for each transaction. Karger's algorithm, minimum cut, dividing the library into two separate sections with the fewest possible connections, akin to partitioning the library into two distinct areas with the least amount of overlap between them. Kosaraju's algorithm, strongly connected components identifying groups of interconnected books within the library, akin to categorizing books into distinct genres or subjects based on their interconnectedness and relevance to each other. Tarjan's algorithm, strongly connected components identifying groups of interconnected books within the library while efficiently handling cycles, akin to categorizing books into distinct genres or subjects while accounting for overlapping themes and motifs. Gabo's algorithm, strongly connected components determining groups of interconnected books within the library with a focus on optimizing performance, akin to categorizing books into distinct genres or subjects while minimizing computational resources required. Hopcroft-Karp algorithm, maximum matching pairing readers with the most suitable books based on preferences and availability, akin to matching patrons with their desired reading materials while maximizing overall satisfaction. Gail Shapley algorithm, stable marriage pairing readers with books in a way that minimizes dissatisfaction and ensures mutual compatibility. akin to facilitating book recommendations and borrowing arrangements that result in mutually beneficial outcomes. Edmonds-Karp algorithm, maximum flow, optimizing the distribution of books throughout the library to ensure maximum accessibility and circulation, akin to managing the flow of books through various sections to meet demand and minimize bottlenecks. Ford-Fulkerson algorithm, maximum flow, determining the optimal allocation of resources within the library to maximize efficiency and utility. Akin to strategically allocating books and staff to different sections to optimize overall operations. Bellman-Ford-Moore algorithm, single-source shortest paths, finding the shortest paths from a given book to all other books while handling negative edge weights, akin to navigating through the library while considering potential obstacles or challenges along the way. Minimum cost spanning tree algorithms, constructing the most cost-effective network of interconnected books within the library, akin to designing a layout that minimizes expenses associated with transportation and maintenance. Eager-Prim's algorithm, constructing a minimum spanning tree by greedily selecting the shortest edges while maintaining a priority queue, akin to designing a library layout by prioritizing the most efficient connections between sections. Chernoff-Bound, estimating the probability of rare events occurring within the library, akin to predicting the likelihood of specific occurrences or trends based on statistical analysis of library usage data. Metropolis-Hastings algorithm, Markov chain Monte Carlo, simulating random processes within the library to generate samples and make probabilistic inferences, akin to using simulated scenarios to analyze reader behavior and preferences. Expectation maximization algorithm, iteratively refining predictions and estimates based on incomplete or uncertain data, akin to adjusting library services and offerings based on feedback and observed usage patterns. Simulated annealing, optimizing resource allocation and layout design within the library by gradually cooling and refining solutions, akin to iteratively improving the organization and functionality of library spaces over time. Ant colony optimization, finding optimal paths and resource allocations within the library by mimicking the foraging behavior of ants, akin to optimizing book placement and retrieval processes based on collective intelligence and feedback mechanisms. Particle swarm optimization, collaboratively optimizing layout design and resource allocation within the library by simulating the social behavior of particles, akin to iteratively improving library operations through cooperative decision-making and adaptation.